Okay, we have to do this using the definition. So this is going to be the limit, as h goes to 0, of
Or g of x.
g of x, well, 1 over g of x plus h, I guess, right? Minus 1 over g of x. I know I'm going fast, but is everyone more or less with this? It's just that, right? That would be, by definition, the derivative of 1 over g. Okay, now we have to do some smart things with this limit. Who has an idea? Tally.
You put h in.
Put h in.
Well, you first like g of x minus g of x plus.
Okay, I think she's saying get a common denominator. Is that what you're saying?
Yeah.
Good. So yeah, so it's g of x minus g of x plus h all over g of x plus h, g of x, h. That's just algebra 1, cool. Just like adding the fractions. Okay, now does anyone see anything? Rayno, what do you see?
That's equal to g of x minus g of x plus h over g of x plus h g of x.
Oh, Rayno sees a derivative hiding right here. That is basically the derivative of g, right? Except we're off by a negative. Who's agreed with me? Yes. So by splitting this up, this becomes the negative. The limit as h goes to 0 of g of x plus h minus g of x over h times the limit as h goes to 0 of 1 over g of x plus h, g of x. I just took the limit of the product and split it up as the product of the limits and also factored a negative out of the numerator. Can everyone handle that in doing it in one step? Okay, what is this guy on the left? Negative g prime. Bam. What is this guy?
G of x squared.
Yeah, 1 over that.
Well,
Yeah. Yep. Ta-da! This is the formula in general for the derivative of a reciprocal. Opposite the derivative of the function over the derivative of the function squared. This is amazing. Can you think of what's your favorite function which is just the reciprocal of a known function? Say secant. Secant, good. Suddenly I can differentiate secant. What is the derivative of secant according to the reciprocal rule? I think of it as just the derivative of 1 over cosine. And according to this rule I just developed, it's the negative, the derivative of cosine.
just positive.
So then it just becomes sine over cosine squared. Brilliant, you just learned a new rule. People usually write this as tan x secant x. Okay, we're back over to the quotient rule. I now know, because I did by the definition of the derivative, reciprocal rule. So this becomes f of x times negative g prime over g of x squared. And then this is plus f prime of x, g of x. I just subbed in the new thing that I learned, yeah? Okay, and usually people clean this up and make it a little prettier by getting a common denominator. So if we do that, we get f prime of g, or sorry, f prime times g minus g prime times f all over g of x squared. This is the so-called quotient rule. It says if you want to differentiate the quotient of two functions that you already know the derivative of, then it's f prime g minus g prime f all over g squared. But it's just an application of the product rule with the reciprocal mixed in. Who's feeling good? All right, last thing, let's do an example. Okay, no time for examples. Read the book for example problems, but you now know how to find, yeah, cut the camera.